All right, here we are. Welcome, everyone. I'm Pete Bernard, CEO of the EDGE AI Foundation, joined here by Jennifer Skinner-Gray from Avnet. Jennifer, welcome.
Thank you. Great to be here.
Yeah. So this is episode one, season one, episode one of EDGE AI Solutions. And just a little brief before we get into the content. So we do a lot of these tech talks, EDGE AI talks, that many of you have seen on YouTube here. And actually, we're on Facebook, LinkedIn, Twitch, and Substack. We do those talks on Tuesdays that are typically very engineering oriented, and they're great. And we learn about a lot of new things about, I would say, the R&D side of Edge AI. But what we've heard is also people want to hear about applied Edge AI. How is this actually being deployed in the real world to solve real problems? And so we decided that was a slightly different audience. I mean, certainly developers want to hear about that, and engineers, but also business decision makers, CTOs, people running, in this case, I guess, apple orchards. We'll talk about that. They want to hear about how this stuff is really affecting different industries. And so we partnered here with Avnet, and I'll let Jennifer kind of give the background on that, but we partnered with them to create this new show called EDGE AI Solutions. And then every month we will dig in with some subject matter experts on real deployed solutions and how they've really been changing industries. So Jennifer, why don't you give folks a little background for those not familiar with Avnet, but everyone knows who Avnet is. But maybe you can give a little background on yourself and Avnet for the audience.
Perfect. Yeah. Well, thank you again for inviting us to participate in this. Avnet is all about solutions. We work with device makers who are designing, choosing components, looking for advisement on technology, options, software, firmware, operating systems, you name it, and especially cloud and AI. So we do a lot of work with companies that are building the next generation of products to address different needs that the market has. And as you mentioned, really excited to roll out this solutions live stream with the EDGE AI Foundation and the partnership here. Really excited about that. We have so many common partners with all the semiconductor suppliers that we represent. And again, bringing these solutions to bear is just a really interesting, and frankly, just it's just innovative and exciting to hear about what people are doing with the technology.
Yeah, and we'll learn a lot too. We're learning a lot about apples today, and I was mentioning before we started. We're actually both based here in Washington State in the U.S. So if you're not familiar with that, there's a lot of apples grown here. So this is like near and dear to our hearts, apples. But we'll talk more about apples. The other thing you mentioned is this is a live stream. So you may be watching this as a recording later on YouTube, but this is a live stream, and so we do have folks here in the chat. And if you'd like to say where you're from, we'd appreciate it, because this is a worldwide conversation that we're having. So, for example, we do have Hachemi from Algeria. Welcome. Let's see, Michael from Bellevue, Washington, kind of close. We have George from Kuala Lumpur, good old KL in Malaysia. We have Mario from Peru. We won't go through everybody, but thank you for joining us. And you will get a chance as Jennifer talks to our guests. Here's Christian from Bremen, Germany. Okay, perfect. I don't know what time zone these are, but thank you for joining us. I guess Germany is pretty reasonable. You put your questions into the chat, and then we will pull them up, and you'll be able to kind of get some answers real time from subject matter experts. That's part of the deal here with the live stream. And so feel free to dig in with all of your questions. And let's see. Oh, there's Phil. Okay. Hey, Phil. Irvine. All right. Irvine's in the house. Okay, great. So why don't we let's see. Let's bring on our guests, and then we're gonna change the little format here a little bit. And Jennifer, maybe you want to introduce these folks, and then I'll fade into the background, and you guys can take over.
Perfect. Well, we're really excited to have Alex and Ivan here on this call from Indeema. They have a broad expertise in a variety of topics, of course, but software, system integration, lots of different hardware products that they can build. But more specifically, we work with them on a drone project, which is cloud connected, and of course, leveraging AI, both on the device, on the edge itself, as well as in the cloud. So with that, I'll just go ahead and turn it over to Alex and Ivan to introduce yourselves.
Great, thanks, Jennifer, and thank you for having us on the program, if that's the right way to put that, on the stream. So my name is Alex Fesiak. I'm the VP of Sales at Indeema. I've been with Indeema approximately about 5 years. My background's in semiconductors, as you know. Indeema's been around for roughly about 15 years. We're an outsourcing engineering firm, primarily in the IoT space. We felt naturally we could migrate in addition to IoT and all the building blocks of IoT, we could get into drone development and engineering services for drones. We've been working with Avnet over the last 3+ years on their IoT Connect platform, which we're very excited about. And on today's program, we'll sort of discuss how we've integrated IoT Connect into our drone platform itself. I'll throw it over to Ivan.
Thank you, Alex. Thanks, Jennifer. Thanks, Pete. I'm excited to be here. I'm the CTO at Indeema, where I oversee hardware design, firmware development, cloud and AI integration. And as Alex said, we take products from the initial ideas and all the way to the production-ready systems. I'm with Indeema for 7 years already, but I have an academic background. I do a double duty as a university professor in electronics and computer technologies. So again, happy to be here and looking forward to an interesting discussion.
Perfect. Well, we had a little bit of fun with the title today, with the No Bad Apples theme, but it truly is a problem, that needs solving in the market, just agriculture in general. So really excited to learn a little bit more about the challenges that farmers are facing, how Indeema is addressing that in the agricultural space in general, and again, how your connected drone and Edge AI are playing a key role in solving those problems. Alex, how do you want to go ahead and kick things off? And I assume we have our slides up, so that perfect, awesome.
There we go.
Great.
Okay, excellent. Yeah, so what we've done is we've created our drone platform, or connected drone platform, and this stream and this discussion is all about farming, apple farming, and how this platform applies itself to that area. There's some challenges in this particular industry, farming and apple farming specifically. First and foremost, there's a huge challenge with the scale and terrain, right? There's huge areas of land to cover. Farmers need to basically, it's hard to access in some cases, some of these farming lands where these trees are situated. And especially after heavy rains and moisture, it's hard to get into these sorts of areas. Another challenge is the fragmentation of data. And what I mean by that is, if you're on this path of basically trying to, take a look at the crops, the apples, so forth, there's lots of data that needs to be collected. It can be scattered, right, depending on, the type of farming you're doing. And of course, there's different tools, different places, and no single view, right? And all of these elements, all of these challenges, when they add up, a lot of these things can be caught very late in the processing, and that causes issues in basically producing quality products, in this case apples and so forth. So what you need to do and how you try to tackle this problem is, we feel drones are a really great solution to basically, review what it is that you're, growing at different stages, and basically put together this data pipeline where, all of this analysis can take place.
Perfect. Yeah, so talking about the drone platform a little bit more detail, I'm really interested. So you presented the challenges that they're facing, but talk a little bit more about how this drone really addresses the agricultural needs.
Right. So there's different sort of elements. I'll kind of explain the building blocks, right? First of all, the drone needs to capture the data. Of course, we have different, camera systems that, depending on the particular use case, will sort of fixate a specific camera with a specific resolution, right? We add telemetry to the drone, so you know where you are on the field, and within which orchard and which tree, for that matter, right? Of course, the big component is the onboard compute, and that's why we're here today. It's the EDGE AI on board that detects, counts the apples, flags anomalies, in real time. And then there's the cloud component as well, right? And there's a lot of flexibility between these systems, right? So it depends on how quickly you need to sort of infer the data, solve the problem. Most of what we can do with our EDGE AI is on board the drone itself, but again, it's cloud connected through IoT Connect, through the AWS system core. So that we could basically utilize the back-end AI usage with regards to any other sort of problems we need solved at that time.
Yeah. Yvonne, can you talk a little bit more about how this system architecture comes together from both a hardware, software, cloud, and other, AI models that you're using?
Sure. So as you can see, we bring together a bunch of different technologies here. So on the left, you can see the drone that handles the flying itself and the data collection. Then we have the connectivity module. So the communication module, let's say, that gets the data from the cloud into the cloud. And then finally, on the right, we do have this IoT Connect platform, which provides the device management, which provides the dashboards, and obviously the AI integration. And this modularity makes it easy to adapt this solution to a particular use case. And at the same time, we can keep the core architecture the same. So this way we can address problems in different industries without redesigning the existing system. So we have tweaks, we can do adjustments, but we have basic architecture that applies to many different use cases.
Yeah, that's really a key differentiator here, right? Is one hardware platform that can be configured to meet the use cases that you're seeing. So that with that, let's just dive a little bit deeper into some of the drone hardware. Yvonne, do you want to just comment a little bit about some of the architecture and how that all comes together?
Yeah, let's dive a little bit deeper here. So at the core of this platform, right, we have the flight stack. This is a custom designed flight stack, the flight controller that runs the Autopilot flight software stack. And this flight controller works in a combination with electronic speed controller, which runs BL Heli software. And this is the heart of the drone, right? And around this, we have a number of peripherals, such as GPS, IMU, barometer, you name it, right? And we, with this basic set, we already can fly and we can do basic things. And after that, it's all about the use case. We can add a specific set of sensors. We can configure the drone for specific needs, and so forth. And why we are not using, let's say, a Linux computer to orchestrate everything? Because we need precise timing and we need to keep the drone stable regardless of what the Linux system is doing. I think there are Linux real-time kernel-based systems, but even then they have a so-called safety MCU, which is capable of resetting the main computer when it's really necessary or in the case of emergency. So this is a general overview of what this hardware looks like. Obviously, we do have a battery, we do have an analog camera, which is primarily used to establish direct link with the ground station and stream live feed a low latency video in case the pilot needs to take over. But for the most part, the intended use of the drone is a predefined mission which can be completely set up and configured from the cloud using IoT Connect.
Awesome. Yeah, and I think it's an important point here where there are multiple subsystems within this drone, from the flight controller to the vision capabilities as well as the sensors, and so there are a lot of different processors, microcontrollers for more precise control, and with that real-time nature. Then also different Linux-based systems depending upon the types of processing, whether it's cloud or edge AI. So this is many systems brought together for this solution. So let's talk a little bit next about connectivity, right? Because you've mentioned that quite a bit, connecting to the cloud and how that is enabled within this system.
Typically, a standard drone has a dedicated control link. Well, typically that works at 915 megahertz. Let's say this is a ERS radio. And it's used for the pilot control. The range is somewhere around 20 kilometers. And we do have a separate video link for streaming that works at 5.8 gigahertz and more or less at the same range, up to 15, 20 kilometers. Then we have Wi-Fi and LTE connectivity for data. And Wi-Fi is usually used when the drone is close to the base, close to the operator, and obviously when a local network is available, while LTE provides connectivity across the field and can be used as a fallback when Wi-Fi is not available. And because these radio systems, they are operating in different frequency bands, so interference is generally not a problem. But even in some cases, if we have to use radios that are working in the same frequency band, then we can have different channels and we can avoid interference if that's the case. And main part of this connected system is obviously the connectivity module, because Wi-Fi or LTE connectivity allows mission plans and waypoints to be uploaded to the drone from the cloud before the mission. So no manual piloting is required to actually fly the drone across the field. And this is our probably main focus for this system.
Awesome. And part of that connectivity, what type of telemetry are you sending to the cloud and how is that used?
I'd say I'd split this in two parts, right? We do send some basic telemetry, like initial IMU data, altitude, orientation, row, pitch, whatever. But an interesting thing is that in the cloud, using in particular some widgets available in IoT Connect, we can actually display some derived insights. And these are very interesting because, for example, it can estimate the point of no return for your drone by combining data like battery level, distance from the base, recent power consumption, and it can predict remaining flight time, for example, based on the actual current drone. And, to put it simply, once the telemetry is available in the cloud, then, the number of possible insights is almost limitless.
That's really cool. And when you look at that and those derived insights, I think that the thing that I start to wonder is, well, how much bandwidth is required to get that telemetry to the cloud? Is it impactful to the system? Is it costly? So what kind of bandwidth are we talking about?
Yeah, I agree that, the traffic can be really cost heavy in some cases, but that's not really a problem for this system, because for the basic telemetry, you normally send 1-2 kilobytes per second. And with AI detections and alerts or notifications, it's, we add maybe another 5 kilobytes. If we are in so-called periodic capture mode, where we capture images every 2-3 seconds, then it's around 1 megabyte per second. And with live HD stream, of course, it might get to 10 megabytes per second or so. And if we need multiple streams from different cameras, then it's obviously 20 or 30 megabytes per second. But as you can see, by carefully selecting the mode and by planning the mission and using the capabilities in a smart way, we can limit the traffic, so it's not a problem at all.
Awesome. Yeah, and I think that's really key, what you mentioned there in terms of the configurability of your software, right? Where you can go into a mode that's appropriate for the problem you're trying to solve or the situation you're trying to solve, which is a great transition to talk about the AI element, right? So you've talked about bringing telemetry up to the cloud and leveraging that and rules and predictive maintenance, essentially, right? To anticipate, the point of no return for the drone. But now, as we look at the vision capabilities and the AI processing that can be done on the edge, you're really optimizing also for how much telemetry is needed to send to the cloud, because you're processing right there at the edge. So talk to us a little bit more about how you're implementing those vision AI models and the capabilities.
Yeah, this is let's say this is a custom part of the setup, right? Completely custom, because even the drone itself, right? It uses the flight controller and electronic speed controller designed by Indeema, but in general, you can basically use any other flight controller and you will still have a flying drone. But this part is completely custom and specifically designed for some of our use cases, right? And we do have the flight controller still, which talks to the single board computer that we have using the Mavlink protocol. And the EDGE AI platform, powered by this single board computer, handles image processing, handles AI inference, and communication with the cloud. And to help the single board computer to handle the AI inference, we do have a Halo 8 accelerator with 26 stops processing power. And we do have a high resolution camera, which is connected directly to the single board computer. And on top of everything, we do have a small controller which can change the camera angle. And this controller is interfaced to the single board computer as well. So we can send the command from the cloud. We can set the camera angle. For example, we can avoid when we fly against the sun, right? We can avoid, too much sunlight going straight into the camera. So we can do many things. And we built this vision and edge module with that in mind. So we have dedicated camera gimbal, we have a dedicated single board computer, AI accelerator, and we utilize the Mavlink protocol to collect the flight controller status and to send commands to the flight controller.
And when you look at the system overall, what type of impact is that AI processing at the edge on the overall power budget for the design? Is it impactful?
Well, a single board computer plus Halo 8 combo typically consumes maybe several watts during inference. And this is a relatively small part of the overall power budget because the motor drive system, and we use 4 motors, so normal quad here. This motor drive system may consume maybe hundreds of watts during flight, and during maneuvers, it's even more. So as you can see, the AI inference does not really have a huge impact on the overall power budget here.
Got it. So, just spending the rest of the time really focusing more on the EDGE AI processing, right? Because we're on this live stream with the EDGE AI Foundation, recognizing that systems and solutions really can't stay stagnant, right? They need to be constantly improving. Talk to us a little bit about the EDGE AI implementation, and help us understand a little bit, why not just send all the images to the cloud? Why do we want to take advantage of EDGE AI in the first place?
Good question. I'd say 3 things: bandwidth, latency, and connectivity. Drone may capture dozens of images per second, but cellular coverage can be limited in some areas, especially rural areas. So running AI on board allows immediate decisions without relying on network connectivity. Of course, there is some logic to it, but the logic is obviously application dependent.
And then as far as when you're doing that processing, roughly how fast are you seeing the AI process the images on the edge?
To give you a practical number here, I think for our single board computer plus Halo system, it's somewhere between 100 and 300 milliseconds. And that includes the time needed to capture the image, to do some pre-processing, to do the actual AI inference, and then to do some post-processing. So this is an integrated latency, I'd say.
All right, and then talk a little bit about the AI models that you're using and why you chose those, as well as maybe other options that might be available.
Well, YOLO model that we use is a very popular choice these days because it provides a very good balance between the accuracy of detection and inference speed, and obviously the deployment simplicity. For drone applications, we often need to process video in real time on a relatively constrained hardware. So that was an obvious choice for this reason. But to add more, YOLO models are specifically designed for this type of workload, and they can achieve good inference latency while still maintaining a decent detection performance. And that said, there are other options. And for example, SSD or single shot detector, which is a bit outdated by now, but still a very lightweight and very suitable for the deployment on the drone.
And I also just, in terms of the improvement of the models over time, the system that you've developed allows you to capture that data, collect that data, aggregate it in the cloud, and then retrain those models, right? And redeploy them to the devices. So, you're always improving, adapting to the use case, taking advantage of the latest and capabilities that the cloud is offering, and then bringing it back down to the device, which is really, a great combination of cloud, plus Edge AI, and great to see leveraging some of those advanced services from AWS, such as SageMaker and Bedrock and others.
Yeah, that's a very useful feature, and this is actually demanded by the industry. So in agriculture, you cannot just keep using the trained model forever, right? You need to rely on your updated image data set. So what we do, we collect the images, we store them in the cloud database, and we do labeling, retraining, and we can, having our pipeline in place using IoT Connect capabilities, we can easily deploy the retrained model on the drone. We can even do, I mean, it makes no sense to do it during the flight, but obviously we can call the drone back to the base and we can redeploy the model there.
Yeah.
Jennifer, we had a couple of cues, couple of questions.
Oh, yes. Okay. Go ahead.
We'll take a little breather here and then move into some questions and then resume. Yeah, so far so good. Really cool stuff. We had a question here from Michael around deployment. Mentioned we're here in Washington State, so he suggested maybe Yakima. But where has this been deployed, or what kind of outcomes have you seen based on this kind of solution?
Yeah, good question. So currently we're working with European companies. We're European based. So, you know, there's been a couple of instances where we're starting to develop this with some of the farming folks in Western Europe. And then I think I saw another question from Michael as well.
Yes. You had a question on pilot to production ready. What's the time between pilot to production?
That's always a great question, and one that's very difficult to answer. It's always based on the use case, of course, right? Depending on what the customer is actually looking for, what they're trying to do. You know, we follow the same process we followed the last 15 years with any kind of IoT development, right? To understand the use case. You know, more information is better than less. To sit down with a customer to review what the needs are. Yeah, it really depends on what it is that what problems are we trying to solve.
Yeah, I had a question related to this. I mean, you know, in my research I've been doing for this show around apples and agriculture, there's a lot of systems happening around agriculture, around you know, pruning and picking and watering, obviously, and other things that, you know, this is part of, but there's other systems in place. Is this typically delivered by like kind of a solution provider that's integrating multiple systems together for a farmer or a person in agriculture, or do you go in there specifically with this? So I'm just wondering, how does this sort of snap into kind of a greater set of systems? What we're seeing now is lots of different systems have to interoperate, and there's a lot of AI models happening on a lot of these systems, and like orchestration and management of these things. You can imagine you've got a bunch of these things working together. How's this thing actually delivered to someone in the agricultural business?
Again, another great question. You know, from our perspective, you know, what we're trying to do is we're trying to work with partners like Avnet, AWS, our experience with Edge AI, to basically bring those elements to, in many cases, not directly to the farmers, but companies. For example, you know, I'll give you an example, right? Drones have been utilized over the last 5 plus 10 years, right? And in farming as well, right? But they haven't been really cloud connected. There hasn't been a whole lot of Edge AI that's been implemented. There's companies that do provide these drones. Those are more our targets. We're trying to work with those entities, saying we are the subject matter experts. We have the partnerships that make sense. We can come in, we can evaluate what you've already built, what you're trying to build, and provide assistance, you know, in areas that we can. So
sure. I see. Yeah, no, I imagine that there's probably some solution providers out there that specialize in sort of the agricultural sector, right? And so they're pulling in your tech and other tech together to solve problems kind of and in the actual deployment. We had one more question here before we cut back to the thing here. Andrew asked, favorite Apple? Royal Gala. Mine actually is the Cosmic Crisp. I don't know if you've heard of that one, but that's kind of a local
Granny
variety.
Smith on my end.
Granny Smith.
Same
Okay.
here. Same here.
Granny Smith. It's a goodie. It's good. It's good for baking too. Okay. So on a more serious note, how many training samples are typical? We're talking about training models. One of the big things with Edge AI is the quality of the data set, which I know is always difficult to get, especially real world data set training. So how do you guys approach kind of the training approach and training samples, and how many samples typically do you need to get the job done?
Well, that's also dependent on the customer, right? But normally we have thousands of images to get to some decent results. But it depends if let's say we want to just do with detection, right? We can simply train the model using the available open data sets, and it works perfectly. But if it's a very specific, classification task from the customer, then we completely rely on the imagery supplied by the customer, and then
I see.
And we are quite limited there. It's normally there's not too many of this available, right? And
yeah.
So usually this is a challenge, I would say.
Right. And I was going to also ask, are you leveraging like synthetic data sets, right? So variants of I don't know, Apple damage or other types of things where it's synthetically generated using generative AI to create the data sets to do the training. Have you started to see any of that?
Yeah, that's a very, let's say, modern approach these days. And we train models on synthetic data for some different purposes, but we are yet to try to use synthetic agriculture data. So that is very interesting, and I'm curious to see where this can get us. But so far, this is something we yet have to try.
Yeah. Okay. Sounds good. Oh, by the way, we had Granny Smith with peanut butter. That was another request on the apples there. Okay, last question before you jump back in. Wireless standards. So that's kind of a critical part, is connectivity in some cases, even though we're running the AI models locally. Halo is mentioned here, 802.11ah. Like, what are you typically seeing now in deployment for connectivity back to gateways or even the cloud?
Are we talking about particular hardware we use for the connectivity module?
Well, I guess and I'm maybe if Harry wants to elaborate, but I'm thinking it's like what kind of radios are being implemented between the drone and something else to communicate any of the metadata. Is it Wi-Fi? Is it cellular? Is it LoRaWAN? Is it?
Yeah, generally speaking, we mostly use standard LTE technology. So
Okay.
I don't want to name particular vendors, but we work with a bunch of companies that provide LTE modems as a complete solution, right? So we install the off-the-shelf LTE module, and we interface the module to our onboard controller, whether it's single board computer or maybe just smaller controller MCU.
Right.
But it doesn't really make a huge difference. So as long as it is compliant with all the 4G standards, we are fine. Sure.
So you're using a more cellular. I think this Harry was asking more about also if you're seeing any Halo deployments. Maybe not yet.
Yeah, we're mostly relying on the cellular connection, especially because many farms are in remote locations where you don't expect the Wi-Fi infrastructure to be that good.
No, right. Okay, sounds good.
Yeah,
all right. Look,
just to add to what Ivan is talking about, some of our partners that we work with. So we we know that satellite-based communications are used in some instances. That's definitely used. LoRaWAN is utilized on drones for drone swarming type applications, where you need basically multiple drones in certain areas. So that's also utilized. Yeah, all the above. People are doing some really interesting things with all of the key wireless standards.
Yeah. Sounds good. I guess Harry was asking, yes, private LTE networks, or are you going over kind of public airwaves?
Yeah, we just stick to normal SIM cards, prepaid plans, and we have it there.
Yeah. Okay. Sounds good. Jennifer, I will turn it back over to you folks to finish or continue on with your stuff here. And I will, let's see, let me get you to a place that makes sense here. Configuration.
Oh, that's perfect. Yeah, so I think we just had a couple more slides and topics here to cover. So great transition into, just let's talk a little bit about what an actual solution looks like, and how that operator, would interface with the drone.
Yeah, this actually summarizes the previous discussion, correct? So we do have the operator who defines the mission, uploads the waypoints. The drone has to fly from A to B to C to D and back to A. Then the drone actually performs the flyover automatically. And as the mission goes, telemetry and AI results are sent back through the connectivity layer to our IoT Connect cloud platform. And from there, we can make the cloud dashboard available from anywhere on any connected tablet, PC, laptop, smartphone. You can see your telemetry. You can see how the drone performs. You can see detection results, images from the drone, and you have also access to commands, right? You can, if you see that something is wrong, or in case of emergency, you can easily recall the drone and send the command to return it to base. And this is basically it. This is very simple. And I think the simplicity is one of the main advantages of this solution. And simplicity is for the user, right? For the end user, because from the technical perspective, it's a very complex solution. But from the user perspective, it's very, very intuitive, and it's very easy to fly the drone across the field, even knowing almost nothing about how the drone operates.
Yeah. I'm glad you emphasized that because it is such an incredibly complex, multiple subsystems, right? But the interface and the user experience really is what's going to determine the success, right, of the product and the use of it. So it's really important to have that sort of interface for the user that will allow them to be successful, right, in implementing and actually leveraging that solution. So this drone is pretty amazing. It can do a lot of different things and be tuned for different applications. But just taking a look at that, Alex, and other different application uses for drones. Can you talk a little bit? You mentioned it just briefly a couple minutes ago, but talk to us a little bit about how those same drones can be reconfigured to address other industry issues.
Yeah, again, great question. I think we've sort of touched on the fact that these are building blocks. The drone itself is a platform, so it's got core capabilities that can be applied to a lot of industries, right? We flagged here on the slide, 3 specific ones, right? For energy and utilities, you can monitor power lines, monitor solar farms, pipelines. If there's any leaks, in any sort of areas, wind turbines. And again, you can monitor all of these aspects pretty much in real time. corrosion, vegetation on these systems, no crews needed in field, up a tower, so very, very flexible, right? In the energy utility space, building inspection, again, you can inspect roofs, bridges, facades. You can do that analysis pretty much in real time, capture all that data. You could take a look at, even evaluate structural issues. There's drones that have very sophisticated sensors on them. And with EDGE AI, they just add a whole new level of capability to basically monitor and any kind of buildings and so forth. And then emergency services, another really interesting area where today drones are being utilized in search and rescue, wildfire monitoring, disaster assessment is a big one. And it's the eyes in the sky. It's actionable info to responders in minutes and not hours. So all of this sort of bundled together with more and more capabilities on the edge, and with the help of software that Avnet provides for building these types of solutions, you're going to get more autonomy, smarter edge, at the AI at the edge, and you'll be able to capture more accurately and actual decisions in flight. So it's a lot of exciting stuff that we're either within or about to approach.
Perfect. Yeah, I really appreciate you sharing all this information. And again, thank you, Pete, for inviting us to join this live stream. And if there are any other questions, I think we can bridge over to those.
Let's see. What do we have here? Okay. Well, Harry was also kind of bringing back the cellular thing, the cost about LTE, but yes, there is a cost. But I assume that that's all sort of aggregated as part of the operational cost of the system. So I don't know if we need to dig into that more, but that's obviously one of the interesting perspectives of using something like Halo. Other question from Michael. Actually, let me change our little layout here to get a little more rational. Where do I go to find this solution? Some marketplace or catalog? That's a good thing. So what's a call to action here for folks that want to learn more about what you're doing in the space?
Where's our marketing person?
Where's the marketing person?
I guess I'm wearing that hat today as well. So yeah, you could approach Avnet, or you could approach us directly online. We have you can learn more about the platform itself. I don't know if we can put it up there quickly on the AWS Marketplace. So we're really excited about that. I believe I can say this, Jennifer. We're one of the first company to be on the AWS Marketplace with our partner Avnet with this drone platform. So that's quite exciting for us.
That's
awesome.
Correct. Yeah. And it's pretty easy to find. You just go to AWS Marketplace in a browser, search Avnet or Indeema or drone. It'll likely pop up right from the search engine. So.
Sounds good. I had another question here from Andrew. Examples where drones take action as a result of detection. So I know we've been talking a lot about observation and analysis of that data, but are you at the point now where you're actually taking action as a result of detection, or how do you think about that?
Yeah, we like a typical action required by our agriculture customers is spraying, right? But that requires a larger drone with some liquid tanks. So what we do, we create an actuator system, so we can actually control different devices that are installed on a drone to initiate spraying or initiate any other required action. But we are not building larger drones, at least not not by now, right? And
Right.
we are just providing the control infrastructure to enable these functions. And should the customer want to build a bigger drone with a specific equipment, we are always ready to step in and enable automation on this large drone.
Makes sense. I'm going to circle back to that comment about the AWS marketplace, because I think that we had that on there. Let's see. Yeah, there you go. So there is your listing on there for the AWS marketplace. So if folks want to take some action on that, they can do that for sure, which is awesome. I was actually going to mention also, the name of the show is EDGE AI Solutions. We've actually launched a solutions portal. So if you go to this solutions portal, I know I'm covering my face here, and I'll go back to this thing here. So if you go to that QR code up there, solutions.edgeaifoundation.org, you will see a whole bunch of industries and canonical kind of use cases for those industries, including agriculture and some of the stuff we talked about today. And then there's links to white papers and other things like that. And in fact, there's a directory of solution providers. So we talked before about who do you go to do the system integration and kind of custom development to deploy these things. There's a catalog of or directory, I would say, of solution providers in there, including Avnet. So that's pretty cool. So you go to solutions.edgeaifoundation.org, click on that QR code or scan that, and you can browse all the latest stuff on there. We will actually be archiving these episodes on that page as well, so people can watch this stuff in the future. So that's another call to action for folks that are listening in or watching. Great. Well, let's see if there's any more questions. Well, thank you very much for this great session. Okay. Appreciate it. Thank you very much. Yeah, I think it's been super helpful to kind of learn about state of the art, what's happening in agriculture. Jennifer, any closing words before we sign off?
Yeah, thank you very much to Indeema. Really great that you could join us. Appreciate all the work that we've been doing together. And thank you, Pete, again, for inviting us to be part of this Solutions live stream. Looking forward to the next one.
Sounds good. All right. Thanks,
Great,
folks.
guys. Thank you, Pete. Thanks for having us. Take care. Right. Bye-bye.